So let's talk a little bit about references and pointers. I know some of you might be new to them, so let's cover them. So what is a reference? A reference is pretty much a variable that is an alias for another object. You create a reference by using this ampersand sign in the variable type declaration. And pretty much anything that you do to this alias gets represented in the object that's getting referenced. So for example, let's say Song Qiao was an int of equal to 5, and I made an alias for it or a reference to it called Sony. If I change Sony later on, like increment it or decrement it, these changes would also be reflected in this variable. Pretty much this is just an alias for this one, and they're connected in that fashion. Not too bad. Just remember that this asterisk goes inside of the type declaration here on the left. So, okay, let's talk a little bit about what pass by value is. Usually when you call a function in C++, by default, most arguments are passed by value. When an argument is passed by value, the argument value is copied into the corresponding function parameter. So in this situation, we have an int num equals 1, and here I called this function change, which takes it in and attempts to change it. However, this wouldn't work because I am doing a pass by value. So if I was to print it out, it would still be 1 instead of 10. Just remember that whenever you pass variables in to a function by value, they get copied. That's the main point of that. So if you don't want to get it copied, you would do something called pass by reference. So pass by reference refers to passing parameters to a function by using references. Pretty much this allows you to modify the value of the argument inside the function, and it avoids making copies. And you don't want to make copies usually for performance reasons. Like you don't want to be copying large images around all over in your code. So here in the example, we have these two variables, A and B, and we call this swap number. The way that we pass by reference is we add this ampersand, pretty similar to how we do references, where we put it inside the type declaration. So we turn A into I, B into J, and then we swap them by putting I into a temporary variable, switching them around, and that's it. So pretty much once I run this code, A would be the value of B and B would be the value of A. The reason that we can do this is because when we call this function and we change this I and J inside this function, they're actually changing A and B as well because they're references to A and B. So what is a memory address? It's very important that you understand just like the basic concept of what a memory address is. It's not too complicated. It's pretty much just the location and memory of an object. Pretty intuitive. And the way that we get the memory address of an object is by using this ampersand symbol, but not in the declaration. Pretty much ever other than the declaration, if you use this ampersand, it will give you the address. So let me give you an example. Let's say I gave you this variable porcupine count, and we wanted to get the memory address of it. All that we would have to do is ampersand porcupine count. So this is saying, give me the address of porcupine count. And this would return something like this. And this is just like a hexadecimal representation of where porcupine count is located in memory. So if I was to run this line of code, pretty much all it would say is that the address of porcupine count is this hexadecimal address. So what can we do with, sorry.
Daniel,
yeah.
There's a lot to unpack on that previous slide. Would you mind talking a little bit more about what it means for something to be in a particular place in memory, and then also either mentioning or saying that it's not important what that hexadecimal thing is, because I think people may not have seen that.
Well, we covered hexadecimal in the exercises.
Do we? Okay, hexadecimal you can skip, but
Yeah, so pretty much
locations in memory may not be intuitive.
So you can think of memory as pretty much as a very big list. And we want to find the location in this list where this object is located in. I could do this better with some pictures. I wasn't going to go too much into exactly how memory addresses were structured. But if you just think about this as memory as like a very long list, and we're just like indexing into that list, and we're just grabbing the object at that index. It's like a very naive representation of what a memory address is. I can talk about more, Kyle, if you want me to.
I guess mainly, does anyone have any questions, or does that concept that you have, the RAM of your computer is like sort of this big chunk, and you can have locations in that. Does that concept make sense to people? If it doesn't, it's probably worth.
So one question that I might have for this is, so for the address, it would work on both primitive and non-primitive types alike, right?
Yes. Like if you have a primitive type like an int and a non-primitive like an object or a class, like this ampersand would give you the address of both the primitive and non-primitive.
Okay, thank you.
And then we've got another question. Ricardo, could you explain what you are trying to ask a little bit more? Because I'm not exactly sure what level of detail you want to go into here.
So I was just asking, like, if we change the value of an integer or maybe like a vector, does the address change or not?
So if you change the value inside of a vector, like where this vector is stored in memory, like the beginning of it doesn't change. So this this memory address, like this asterisk points to be the beginning of like the memory chunk. So like if you like add to like a vector an array, the beginning of it will still be located at the same memory address.
Yeah, and in general, if you that holds for pretty much like everything, right? If you for any primitive type specifically, right? If you assign to it, its address is not going to change. In general, actually any type, if you change its value, its address is not going to change. The case in which the address changes is when you have like dynamic memory, which I think we touched upon a little bit last time, right? So for example, if you assign a unique pointer to yes, it is very different from how something like Python would work. But if you have like a unique pointer to something, and then you assign that to a new unique pointer, right, to a new place in dynamic memory, the underlying address that you can use with .get, that may or may not be familiar, because I think unique pointers were in the videos that you guys were going to watch, but I know that not all of you probably got to them. But essentially, like if you have some memory like that, then that can change the address that something is pointing to. Another gotcha there, and I just want to make this clear with the example that you just gave. So if you change the value in a vector, right, it's not going to change the addresses. But if you add if you add elements to the end of a vector, it actually can change the addresses of the elements of the vector. So like that's sort of a weird gotcha that can happen in C++. That's my peanut gallery comment.
Any other questions on memory addresses? Okay, sounds good. Let's move on to pointers. Interesting point. Pretty much a pointer is a variable that stores a memory address. That's just the main concept. It just stores the memory address of a particular type. And it's created using the asterisk sign inside of the variable declaration. So let me give you some examples of the declarations of some pointers. So here we have number, and this would be described as a pointer to an int. So this means that number would hold, can possibly hold the memory address that would point to an int object or an int type. Decimal would just be considered a pointer to a double, and then a character would just be a pointer to a char. So let's talk a little bit about like how you populate these pointers to a type. So we just learned that, actually I want this pointer thing. Anyways, we just learned that if we have this variable, let's say gum is an int, and we did ampersand gum, this would give us the memory address of gum. And then we can store this memory address of gum into a pointer. And this pointer would be a pointer to an int. So yeah, so just to say that again, it's really important that you understand this concept right here, that you understand what this line does. So to repeat, gum is an int. Asterisk gives us a memory address of gum, which is of type int. And this is going to get stored inside of a variable called pointer, which is of type pointer to an int. So one important note about writing these, just like how to declare them, is that this asterisk does not necessarily need to be touching the int, the type, or the variable. There's some flexibility in terms of like if you want to put a space before or after, or before and after. Normally, most people have their preferences. I think for the exercises, we use this. Usually most people prefer one of these two. It's pretty standard. But yeah, at least for the exercises for project 3.4 and 3.5, we'll use this convention. But these two are pretty popular. Does anyone have questions? Like, does everyone understand what this line does per se?
So there are a couple of questions if you want to check the chat. One is, so reference is and gum, and pointer is int star pointer. Just a clarification with the syntax and how you should probably think of it. I'm going to type some things in chat, but basically so if you have int and gum, this whole the whole int and, everything that's in int and is the type, right? Similarly, if you have int star gum, right, everything that's got int and, the int star stuff is the type, right? So those are like a pointer to int is a completely different type than just an integer, right? And technically the syntax here is a little bit wonky, especially when you're declaring multiple variables in one line, which is why we don't go over that, because it's like really annoying and kind of a stupid relic of old C stuff. But essentially, like, the star is actually declared as part of the type, right? That's the difference between how you declare pointers and references. And then the other comment is, so if we just put int, it won't store the address of gum. So if you say equals gum, that's just going to make a copy of gum, right? Hopefully that answers that. And then a couple more. Daniel, you want to take these or you want me to grab them?
It's up to you. So what is the purpose of a pointer and like how is it different from a reference or an alias? So it's pretty different from a reference or an alias because a pointer, like in all simplicity, it just stores a memory address of a type. We'll figure out what we do with these pointers later. But like if you just need a definition of what a pointer is, all it does is it stores the memory address of a type. And like, we're going to talk about this more later, but this ampersand is used in two ways. So don't refuse like getting the memory address of a variable and references confused. We will talk about this in like maybe like 2 slides, but just like in shorthand, if this ampersand is to the right, or like if this ampersand is not in a declaration, like where we define the type, then it is asking for the memory address of this variable. And this memory address is probably some like hexadecimal value. And if we want to store this hexadecimal value, we have to do it in this int pointer. This is its own type. You can't remove this pointer thing. You need to make sure that like this hexadecimal needs to be stored inside of here. Let's see. So ampersand gum will return a memory address, and you want to store this memory address inside of a pointer to an int. So I don't think you can remove this asterisk. So can you still technically have a pointer even if the reference is no more? I wouldn't really say it's a reference. I would just say like, can you have a pointer to a memory address and nothing useful is at that memory address? Yes, you can have that. That's fully possible where you grab the memory address of gum and you store it inside of this variable, and then later on the code, you still are storing this memory address, but there's nothing useful at that location. There's just junk.
So we've got one more question, and I want to use it to highlight the difference between C++ and Java in this regard, because so far we've mostly been talking about primitives. But this question talks about if you have a cat object named meow. Daniel, do you want to take that, or do you want me to grab it?
You can grab it.
Okay, so this one is talking about how this works with objects. And this is, I want to point this out specifically, like I said, because this is very different from what you might have seen in Java. So in Java, everything is passed by reference when you have like objects, right? When you have things that aren't just integers or floats or things like that, right? And that means that, yes, it is true in Java, if you have cat other equals meow, right? That will make other point to where meow is in memory. In C++, it's completely different. In C++, saying cat other equals meow will actually copy the value of meow, right? It will take meow and copy all of its variables and make a completely separate copy of it and then call that other, right? And if you want to make a pointer or a reference to where meow is, you have to use either I'll type it out, but you would have to use cat ampersand other equals meow, right? And that would make a reference to meow, or cat star other equals ampersand meow, which would make a pointer to the address of meow. Does that settle your question? Hopefully.
Wait, actually, isn't it the Java, like almost all of it is passed by value?
Yes. So So Java, all objects are passed by reference, I believe. It's been a while, but I'm pretty sure that's the case. I do not use Java regularly. That said, yeah, everything is passed by reference, except for primitive types. So primitive types in Java, like int, float, those are all passed by object, or sorry, passed by value. Yeah. Yes, thank you for confirming that, guys. I wanted to make sure that I had that right, because I have not had to use Java in a long time, thankfully.
Okay.
So one other thing is that, technically speaking, there's not that much of a difference between, like, if you look at what the generated, like, what the output of the compiler is, references will give pretty similar thing, like they'll do a very similar thing to what a pointer does. There's a reason we're talking about them at the same time. They're very similar. The biggest sort of differences are that one, you can't reassign a reference to point to a new variable, whereas you can easily reassign a pointer to point to a new variable. And then two, it's very easy to create a pointer that points to nothing, essentially. You can make a pointer that's just to memory address 0, and we call that null, right? We try not to do it, but you can do it. And in certain situations, that can have meaning. Sometimes we use that to denote no object here, although it's not good practice to do that. And then for references, you actually do have to initialize it to refer to some value. Yeah, I know this is a complicated topic. Like, this is one of the sort of trickiest intro C++ things. So I appreciate y'all's patience bearing with us on this.
Okay. Any more questions on pointers before? I know pointers are pretty, you can go down a really long rabbit hole with them. I kind of just want to cover the basic concept. Does anyone have any questions on the basic concept of pointers before I move on? Some of the questions might get drowned. But anyways, I will move on. So let's see, dereferencing. What does it mean to dereference? So dereference, you will also use this asterisk symbol. But please do not confuse this asterisk symbol with like creating a pointer. Pretty much when this asterisk symbol is in the type declaration, like pretty much just to the left, it is making a pointer object. But if it's anywhere else, like not creating a new, declaring a new variable, it means that you're dereferencing a pointer. And what does it mean to dereferencing a pointer? It just means that you're obtaining the value pointed to by the pointer value. So let's give an example. So let's say that we have this variable gum equals to 3, and we make a pointer to this gum variable. So we talked about this in the last slide. We got the address of gum and we stored it inside of this end pointer. And then we want to regrab the value of gum. So the way that we would do this is we would dereference this pointer, which pretty much means is we would look at the memory address stored by pointer. So pointer stores some hexadecimal value. We're pretty much going to be like, okay, let's look at what's stored at the hexadecimal value at the memory address stored by this pointer. And let's just grab that value. So here we are dereferencing the memory address of gum, and located there is the value of 3. So dereference here would just be the value of 3. So let's talk about the double meaning of these two symbols, ampersand and asterisk. It's very easy to confuse them, but please remember that they're different. And the difference comes from if they're used in a declaration or not. So let's talk about ampersand first. So if ampersand is used in a declaration like this, then it is a reference operator, and this would be an alias. If it is not used in a declaration, like here, that means it is an address operator, meaning that this would return the address of porcupine count. Two different scenarios, they do two different things. One, it's in the type. One, it's literally anywhere else. This one makes an alias. This one gives you the actual memory address of this variable. So asterisk, pretty similar. If it is in the declaration, it will create a pointer. So here we can store the memory address of gum inside of this pointer. So it makes a pointer if it's in the type declaration. If it's anywhere else, it is dereferencing the pointer. So here we have a pointer, we're dereferencing it, and we get the value that is there. Just the easy way to remember is if the ampersand is in the declaration, it's reference. If it's not, it's address. And if the asterisk is in the declaration, it's a pointer. If it's not, it's dereference. Yeah. You can usually just think of the asterisk as like dealing with pointers. You just need to remember this caveat though. It's very important to remember because it might screw you up if you forget it though. Yeah, so let's talk about the arrow operator. Pretty much the arrow operator is pretty much syntactic sugar for dereferencing a pointer and then grabbing a value from it. So it is, if A is a pointer to an object, then A arrow B is accessing like the variable B of the object that it points to. So just know that this is syntactic sugar for this right here. So let's give you an example. So let's say A is of type some class, and then we grab the address of A. So right now, X is storing the memory address of A. And so if we wanted to get this B variable, the normal way would just be like you have A, you do A.B, and it tells you 5. But let's say you were just given like the pointer. You could do X point arrow operator B. And this just stands for, let's dereference X. So it gives you A, and then dot B. It's pretty much a syntactic sugar. It's used pretty often just because we use pointers a decent amount, and it's just way nicer to do this arrow operator to grab a field from a class than it is to like dereference it and then grab it again. Yeah. Let's see what single questions we have. Why would we use a pointer over a reference when every time you want the value to serve? So why would we use a pointer over a reference when every time you want the value stored in the parameter, you have to do, you have to dereference it, or can you pass the memory address along when you need the value? Normally we use pointers more just because we pass around, like it's just easier to pass around. Like we're not going to be passing around like aliases, like references to the variable. Yeah. Let's see. So the reason, actually, star foo without these parentheses dot bar is different. So you have to dereference it within parentheses and then do dot bar. If you did like asterisk foo dot bar without these parentheses, it would do the dot first and it would completely break your code. So like the parentheses are pretty important for this. But yeah. So let's quickly review pointers. So let's say here, I'll just go over a quick example. We have var1, which is equal to 100 of type int. And we are going to grab the memory address of it and store it inside of a pointer to int called pointer. This is just shorthand notation for pointer. So here is a visual diagram of it. So pretty much we have one, it has this value of 100 stored in memory. the actual location in memory is this hexadecimal number. And when we make this pointer, it pretty much just grabs this value, throws it in there. So right now, this int, this pointer to an int, literally just has this value to it. If you understand this example, you're in a good position. Yeah. So let's talk about smart pointers. So what are smart pointers? Pretty much a smart pointer is a pointer-like type that provides automatic memory management. So pretty much when a smart pointer is no longer used, the memory that it pointed to is deallocated. So like we talked about, there's some problems with raw pointers, mainly that you can forget to delete the object, and it can cause memory leaks as well. So like the example that we talked about, like you can have pointers pointing to memory addresses that just have trash there. Smart pointers are just a nicer way to do automatic memory management, and they're a bit more flexible. The only problem with it is they have a bit of a performance penalty. So let's talk about the main two examples of smart pointers that are often used: unique pointers and shared pointers. So what is a unique smart pointer? So a unique smart pointer is pretty much a smart pointer that has unique ownership. What does that mean? That means that it does not share its pointer. So that means that you cannot have two unique pointers that point to the same object. It has unique ownership, meaning that if you have one unique pointer, it will point to one object, and multiple unique pointers cannot point to that object. It's pretty much a one-to-one mapping. You cannot have a many-to-one mapping. And important caveats to note about unique pointers is that they cannot be copied because of this principle of like one-to-one. So if you want to have another variable point to an object, you have to transfer or move ownership to the other object, to the other pointer. So in this situation, if we have pointer A pointing to some object, if we wanted B to point to this object, we would have to transfer ownership. So one of the nice things about unique pointers is that like if they're destroyed, meaning like one example of this is when they fall out of scope. So like you're working with some unique pointer and then it just falls out of scope because it was only used inside of our particular function or so on, then the object that's being pointed to by the pointer is deleted. It's just like nice memory management that you don't have to like think about it. It's much cleaner. So also when you want to construct a unique pointer, you do this make unique helper function. So let's give a quick example of how you would do this, how you would use unique pointer. So here, let's make a object of type song. So here we'd say make unique this object of type song, and then call the constructor with these arguments. And then you would store that inside of this unique pointer. And pretty much what this looks like is this unique pointer is pointing to this object class. And you can use it as normal, just like how you would use a normal pointer. You can like dereference it, move it around, and so on and so on. Now let's say we get bored with pointer A and we want to transfer it to pointer B. We can't have pointer B also pointing to the song object because only one can point to it. So we can call this standard move, which pretty much just moves this arrow from like pointer A to song and transfers it to, I kind of think it's kind of annoying. I don't know how to remove it. So it transfers it so that pointer B points to the song object. Pretty much for unique pointers, as long as you understand that it's a one-to-one mapping, so you have unique ownership, And in order to transfer it, you have to call this move function. And to initialize it, you do this make unique. You're good. Yeah, auto is pretty much shorthand for this has a type, but I don't want to write the whole type. So when you compile it, just look to see what this function is returning. So like it's returning like make unique of type song, and just put it here. It's mostly used to it's like a nice it's just nice so that you don't have to like write out long types, pretty much. So let's talk. Sorry.
If you get confused by auto, in this case, you can just replace the word auto with std or with unique pointer angle bracket song. Right? It's the exact same thing.
Yeah. So let's talk about shared pointers. So a shared pointer is different from a unique pointer in that more than one owner will be able to manage the lifetime of the object. That means that you can have multiple pointers pointing to the same object, and they'll also point to something called a control block, which will keep track of how many pointers are pointing to this object. So pretty much whenever a shared pointer is made, it will point to some object, and it will also point to this control block, and it will increment this control block saying like, oh, I just started pointing to my class. Please keep track of me in your count. And whenever this gets deleted, like if it goes out of scope or is removed, this number will go down. It'll just say like, oh, I'm going to go to my control block and decrease this number. And the reason that we have this control block is that whenever this control block goes to 0, my class will be deleted. So one of the benefits of this is that you can have multiple pointers pointing to the same object. And when all of these pointers, all these shared pointers are destroyed, the object will like delete itself automatically. Like you don't have to do it yourself. Yeah, and the way that you do this is kind of like how there was make unique for unique pointers, there's make shared for shared pointers. Any questions on make unique and shared pointers before I move on to ROS concepts? Okay. Sure.
When would you want to use a shared pointer instead of a unique pointer?
So a shared pointer would be useful when you need a pointer to the object in multiple places and you are not sure will be deleted last. But you want to make sure that the object is removed at the end.
And when do RoboJackets teams use shared pointers? Usually. This is a leading question, but
well, I think we all use them differently in different
I think the answer
locations.
The answer I'm going for is like pretty rarely, right? Usually, at least I don't know about you guys, but for the most part, other than things dictated by Ross, RoboCup does not use a lot of shared pointers. I think that's pretty shared between the teams. Maybe not. Maybe I'm misspeaking.
Yeah, RoboNav doesn't use.
RoboRacing uses them sometimes. Mostly with like some stuff like ROS controllers, it's nice to use shared pointers. But we can talk about that more like in individual teams, like how we use shared pointers. But I think RoboRacing is the one that probably uses most in some areas. But yeah, let's quickly review what these smart pointers are. So shared pointers, you're sharing a resources, meaning that you could have multiple pointers pointing to the same object. Unique pointers are having multiple pointers point to the same is not allowed. You can only have one pointer pointing to the storage, and you cannot share resources. It's the main difference between the two. But yeah, they're used pretty sparingly between our repos, but we still wanted to cover them because we thought they were important. Let's talk about ROS. Okay, so first of all, what is ROS? So ROS, also known as Robot Operating System, is a flexible framework for writing software, robot software. And it's pretty much just a collection of tools, libraries, and conventions that aim to make like robust robotic behaviors as easy as possible. You guys might have watched already, so this is review and to introduce the concepts. But yeah, pretty much it allows you to, it makes it simpler to do robot behaviors, and it already has a framework with like a bunch of packages and its own structure. So pretty much in ROS, so what is ROS? Like most of the stuff in ROS is comprised of nodes. So what is a node? A node pretty much handles a singular part of the problem that you're trying to solve with your whole robotic system. So each node has like a single purpose. So example of some single purpose node is like this one deals with camera driver. This one deals with like image processing. This one deals with like image viewer. Pretty much single responsibility for the nodes. And the reason that like nodes are single responsibility is because it reduces code complexity. It's much easier to understand when you have a more, when your system is not extremely coupled together, and allows for better fault tolerance. It's more easily, it's easier to understand what's going on, and it's language agnostic. What does language agnostic mean? ROS supports C++ and Python, so if you decide to write a node in C++, it can still communicate with a node written in Python, which is really nice, just in case if you want to like write a node in Python. But yeah, so like here is an example of what some nodes would look like. So maybe you would have a cluster of nodes for camera stuff, you would have a cluster of nodes for motion planning, and you would have a cluster of nodes for hardware control. And each one of these nodes is only doing a small part of what your overall task, the robotic system is. Which is better for ROS, C++, or Python? Normally, at least for racing, we do C++ for anything that is very performance based. So anything where like performance is key, we normally do C++, and anything that we're like prototyping, sometimes we'll do Python. I think some of the teams do it a little bit differently, but like that's usually a nice convention. Like normally we write we wrote almost everything in C++, I think, for both RoboNav and RoboRacing.
Yeah, for RoboNav, 99% of our code base is in C++ ROS, and then the bit that's in Python is just our neural network stuff. And so that's our only node that's written in Python.
Yeah, so like sometimes we would write something quickly in Python if we want to like prototype a behavior, and we don't want, like we just want to write it quickly just because sometimes it's easier to write in Python. But yeah, like everything that we like run on the actual car, that's not like a utility script, is normally done in C++. So one of the questions is there any reason we use ROS1 over ROS2? We made, so at least, sorry, someone wants to say something?
No, just go.
Sure. Well, we were going to make a big push. This is more like what the original plan was. Like we were going to make a big push to try to get onto ROS2, but our whole system works on ROS1, and like Some people would say that ROS2 documentation isn't the greatest in the world, so it might be too early. And also, like, a lot of the sensors we're using, at least for RoboNav and RoboRacing, are support ROS1 instead of ROS2. So it makes the transfer a lot more difficult for us. Like, IMU stuff or LiDAR stuff there's already packages that exist for ROS1. So transferring to ROS2 would like be a decent amount of overhead if we didn't want to write the packages ourselves. And there's a lot of other benefits to it. Yeah.
Yeah, and for RoboCup at least, since we weren't on ROS at all before, we're just going straight to ROS2. So if you're on RoboCup, you'll be using ROS2.
Yeah, ROS2 is more future safe.
Yeah. RoboNav plans to write the URC rover code in ROS2, but we're keeping ROS1 code for now.
Yep. Okay, so let's talk a little bit about what can we do with these nodes. So most of the time, these nodes talk to each other using something called the publisher and subscriber model. So what does that mean? So pretty much we have a sender node that we call a publisher that sends messages over a topic to receiver nodes that we call subscribers. So let's give a quick example, So like, let's say you were like a radio company that was sending, like that was broadcasting over a certain like frequency, and people on their radio could hear like what you're broadcasting. Pretty much the broadcaster would be the publisher. The frequency that you're sending over would kind of be like the topic. The topic is a one-way communication channel with a unique name. So this would kind of be like the frequency. This topic name has to be unique. And the messages would just be the messages, and people with their radio would be the subscribers. So the way that this works, normally a publisher sends messages over a topic, and either one or more nodes can be subscribed to it. So like multiple people can be listening to what this node has to say. So an example like of what a node would be is like this node would be publishing what the current speed of a vehicle is, and it would like be saying like it would be like vehicle speed, and it would be publishing like the speed, and a bunch of other nodes would be listening into it just because they need that information to do other operations inside their code. So let's talk a little bit about topic names. I said that they have to be unique, and pretty much the naming convention follows a hierarchical naming structure. Pretty much, if you're familiar with the way file path naming structure work, is like very, very similar to that. Pretty much, if I was to give you this, like in file path, you would say that home and RoboJackets is some sort of directory, and robots status report would be some type of file. Pretty much these things that we would think as directories, we kind of call namespaces in ROS. So home RoboJackets we would consider as a namespace. And the way that we can write topic names is either relative, global, or private. Relative and global should make sense if you work with file paths. Pretty much the resolution is done relative to the node's namespace, so relative to where your current directory is. Global is relative to the root directory or the global directory, and then private is a bit more fancier, but it pretty much just converts the node name into a namespace. So I'll quickly go over just like an example of how each of these kind of differ. So let's say I told node 1 I told this node to publish on a topic called bar. No slash, no nothing, just bar. That would be classified as a relative topic name. So that the way that we would resolve this is that we would look to see if node 1 had any namespace, which would be this global namespace, and then we would just add it to the prefix of this name. So pretty much, here's another example. How do I get rid of this thing? It's pretty annoying. Like So for this one, pretty much we tell it it's bar, we look at the namespace of this, which is /wd/, and we add it to the prefix of that. Pretty much just normal relative. Just look at the namespace, add it to the prefix. Global is even easier. It's literally just a pass-through. We're literally saying, node 1, please publish /bar. And it's like, okay, I'll just publish /bar because that's an absolute topic name. And then private is like slightly more fancy. All it does is that if I tell node 1 to publish on ~bar, it looks at node 1 and it just appends the name of the node to what it's going to publish. So here's an example. I told node 1, please publish ~bar. And then node 1 is like, okay, I'll publish /node1/bar. So what it did is it grabbed everything that's here and just added to the prefix of that. It's different from relative because relative does not grab the name of the topic. And here are some more examples if you want to look at it. Relative is pretty simple to understand. Global, it's literally just pass through. And then private is only slightly more fancy just because you have to include the name of the node inside of the namespace. But yeah. So let's talk about ROSMaster. So ROSMaster provides naming and registration services to all the nodes in the ROS system. So pretty much it just keeps track of the publishers, the subscribers, the topics, and the services, like all the main stuff in ROS. So the role of ROSMaster is to allow individual ROS nodes to locate one another. And once individual nodes have located one another, they start connecting to each other through peer-to-peer. So here's an example. I'm a new node, and I want to communicate to all the other nodes that speak on /topic or like /speed or whatever. And so I'm just going to say like, hey, ROSMaster, please register me, like I am a thing, and tell me all the nodes that publish on /topic. And ROSMaster would be like, okay, here are all the nodes. And then the new node would look at those and then just start communicating peer-to-peer, like directly to those nodes. So it's pretty much just like an orchestrator, or it manages like the connections. And the way that we run this is ROS-core. Please remember that this is the first thing that you need to run before you start like running nodes, because if ROS-core is not alive, when you start a node, like it won't be able to register itself and like look for other stuff. So ROS-core is usually like one of the first lines we run. So let's say we want to just run a normal ROS node, like we want to do some code. So how would you do this? So first, you would want to make sure that you source the noetic setup.bash. And normally this would be done inside of your bashrc. And this bashrc gets run every single time you open up a new terminal if you're using like a bash terminal, which is the default for like Ubuntu. Those of you that are a bit more fancy with your Linux distributions might use like Z shell or something else. But by default, Ubuntu uses bash for its terminal. And every single time you open up a new terminal, it will look at this bashrc to see what commands to run. And normally source blah, 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 noetic.bash is one of them that we ask you guys to include later on. For those of you that are doing ROS2, it will be Foxy instead of setup, but like just for ROS1, it's noetic. And what this does is that it pretty much tells your computer about all the ROS commands that exist. So like if I did not do source noetic dash setup, it would not know what ROS-core is. It's important that you run this command so that all the command line ROS tools are available for you. So once you've done this, or if it's done automatically in your .bashrc, then you're able to run ROS-core, which is this ROSMaster that we just told you about, which deals with all like the registration. And depending on who you ask, most people say like, oh, run ROScore in another terminal, or you could just do ROScore and then press enter, and it'll just like run it in the background if you don't want to like see it. I normally just do ROScore and just keep it in the background, but some people want to kill it manually, so they just run ROScore in another terminal. And then once you have ROScore running, you're free to go. You can start running nodes to your heart's desire. So the way that we run a node is, we'll talk a bit more in detail in future weeks, but just in a quick preview, we would just say ROS run, and then where the node is located, and then the executable for the node. So let's talk a little bit about like what some command line utilities Noetic gives us. So these are the most used command line tools that we use when dealing with ROS. So it's important you to dedicate some of these to memory, if not almost all of them. So ROScore, completely essential. You need to know that you need to run this every single time you are going to run a node. And ROS run pretty much just allows you to run a node. Pretty much it allows you to run an executable in an arbitrary package. We'll talk more about packages in the coming weeks. ROS topic, we talked about topics where they're pretty much just one-way communication channels. ROS topic allows you to get information about this channel, so you can like see what's being published on these channels. You can see how often things are being published on these channels, and it allows you to publish things by yourself on these channels. So you can get information, you can see what's being printed, and you can publish your own things. ROS node just gives you information about nodes, so it tells you like who it's like, what is it doing. You can kill it, and you can also see what nodes are alive. These are just some common tools, but it's very important that you at least know these four. They're pretty intuitive. I hope we can go over them more later. Let's talk about a little bit about rossrqt. So sorry if I'm going a little bit fast. So rossrqt is pretty much just a GUI system for ROS, which allows you to import a bunch of plugins. And you can run it pretty easily just with like RQT once you like source your Noetic setup. And it's pretty much just a little GUI, and there's a bunch of plugins like plot, topic messages, stuff like that, that will make it easier for you if you like don't want to be dealing with like command lines all the time. And it's very good for like visualization of stuff. So what are some commonly used plugins? So rqtgraph is a very nice GUI plugin that allows you to visualize the structure of all the nodes that you're currently running. So like here is a very complex graph. It's not that big, but like here's an example of how one can look. Here's a very simple one. Pretty much the way that this works is if it's a box, that means it's a namespace. We talked a little bit about namespaces are kind of like directories. And inside of here, we have a node. These ovals are nodes. You can recognize them because they're oval. So this node telop turtle is publishing on the topic turtle1 command velocity, which is this box. This is a topic. So this node is publishing this topic called this, and these two nodes, turtlesim and myturtle, are subscribing to it. So it's pretty much just a flow diagram of where information is going in your node graph. So pretty much here you can see like, oh, information is going there, 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 and you can just see how everything is connected and who is requesting what information from who. Once you start getting to like more larger architectures, these graphs start getting larger quickly, but it's good just to visualize like what is happening. Topic monitor and message publisher pretty much is just a GUI for ROS topic. So ROS topic just gives you information about like what's happening on each topic. So here it tells you that in turtle1 / command velocity, it tells you its type, how frequently it's being published, and like the message that's being published. And then message publisher just allows you to publish your own messages onto a particular topic. Just GUIs, Normally, they're not that used just because it's easy to use the command line versions of it, but I'm just showing you the plugins that exist. RQTplot is pretty useful for seeing how particular data changes over time. Pretty much you can like plot the position of stuff, or just like any messages that changes over time. You can plot in here. Just useful plugin. Image Viewer is just another plugin for viewing images. The main reason for me to show you this is just so you know that there exists GUIs for ROS just for visualizing most of the message types that exist that can be published over topics. Okay, so I covered a decent amount. I covered a lot about references and pointers. For some of you that have never dealt with C++, references and pointers always hits like a truck usually, just because now you have to start thinking about like memory addresses and what is pointing to what. We talked about smart pointers, which is just a easier way to deal with like object lifetime management, just to make sure like an object is deleted after you're not dealing with the pointer anymore. And we talked about ROS introduction. What is ROS? What are nodes? How do they communicate each other? And so on. Sorry if I went for a bit. I just feel like some of the concepts we addressed need to be said in detail. Any questions, I guess, before we go into our breakout rooms to talk about examples and like to review all the stuff that we learned? Okay, so we will be breaking out into the breakout rooms, and during the breakout rooms, the subteam leads will ask you questions about like the stuff that we learned to them. Please make sure that you understand like the stuff that we'll be covering there, just because we'll be covering like reference and pointers more in detail. Make sure that you guys understand it. Kyle, do you want to say anything else before we move into breakout rooms?
No, I will update the classroom, the like assignment page with the new assignments, and I'll also send them to to each of the breakout rooms. But please fill out the attendance link if you have not already done so. Let me grab a new one because it's been an hour. Please, so if you have not already filled this out, please do that, or not filled it out, please click the attendance link so you can do that. Other than that, breakout rooms. Does anyone have any questions for me? Anyone who's staying in here? If not, I'm probably going to hop around to the breakout rooms.